In this video I'm going to be going over oxidation reduction reactions, aka redox reactions. Oxidation reduction is like the full name for it, but most people who have been in the business for a while, they just call it redox reactions because that's much easier. So there's two ways that you can think about remembering this. There's actually many different ways, but these are the two that are most commonly seen. So these are just kind of like acronyms to help you remember how these work. Because memorizing isn't fun. It's fun to make little acronyms to help you, or little sayings to help you. So the one that I use is Leo says grr. Leo as in like a tiger, grr as in like, they're like growling or something. I don't know. That's what I learned in high school. Stuck with me ever since. I know Professor Sherlock likes to use oil rig. But so let's take a look at like those two things and what those mean. So Leo says grr means that LEO means loss of electron is oxidation. So loss of electron is oxidation. Says GER, GER is gain of electron is reduction. And then oil rig is where oxidation is loss and reduction is gain. So I like to do Leo says GER because instantly you can be like, all right, we're losing electrons. What is that? Losing electrons, oxidation. Okay, cool. Gaining electrons, oh, that's reduction. Here you kind of have to like work backwards. You're like, loss is oxidation, but either way, like everyone does it differently. I like to do Leo says GER. Oil rig never really stuck to me, so yeah, I figured I'd share that one just so you guys can have that in your little, I guess in your pocket. I don't know what the saying is. Okay, so let's go over some definitions that you may need while you go through this. So the main definitions are oxidation, reducing agent, reduction, and oxidizing agent. All of these sound very similar, but they all mean different things, right? So as we know from Leo says GER and oil rig, oxidation is a chemical that loses electrons through a reaction, right? So during the reaction, it loses electrons. That's all you really have to know. Reducing agent is a chemical that causes a reduction. So it causes another chemical to have a reduction, right? So anything that is oxidized will be a reducing agent. That's just something you have to like memorize, right? And then something that is reduced, or the reduction, is a chemical that gains electrons. And then anything that is reduced is an oxidizing agent, right? So that's a chemical that causes an oxidation. So something that is reduced is an oxidizing reagent because the other thing loses electrons because the reducer gains the electrons, right? And then vice versa for the other one. So that's why they're called those two different things. So I'm going to quickly go over some examples. So I have an example and then I also have a practice problem. So here's an example here, right? So the question says, determine which is oxidized, reduced, and which is the reducing agent and which one is the oxidizing agent, right? So first thing that you want to do is you want to determine what things can gain and lose electrons, right? So usually what we're looking at there are the metals, right? The things that are written first or, have a positive charge when they are in a reaction, right? So those things, I'm going to do this in pink. Those metals that are usually positively charged are here. So we're going to look at those charges right now, currently as they stand. So in the, we'll do copper. We'll write them out. So I'm going to do copper. That is not how to spell copper, guys. I don't know how to spell copper. Okay, we're just going to do this. I don't think that's right either. You know what I mean. Copper and silver. So copper has a charge of 0, right? Because copper, anything as a solid doesn't have a charge, but if it's aqueous, as we learned in the last video, and it is something that is an electrolyte, it has a charge. So in this scenario, copper starts out not having any charge to it. Oh my goodness, you know what I actually just realized? We need to balance this equation. So let's do that now that I just remembered. I literally wrote this out 5 minutes ago and I forgot that was the first step. Okay, so NO3, all right, that needs to be a 2 here. I think that's it. I'm gonna look at the... This is so embarrassing, guys. I had it somewhere. Was it chemistry solutions? Yeah. Yep. Okay. So that's all we have to do. We have to add the 2 there, and then that means we have to add a 2 here. Okay. Whew. Okay. Oh, goodness, that was almost bad. Okay. And that matters when we're going into, like, reducing and oxidizing and how many electrons you actually gain, because we have to multiply it by the amount of moles in a reaction. Okay, but for copper, we don't have to worry about that, right? So we start out with a charge of 0, right? And then in the product side, we have a charge of positive 2, right? And we know that because silver, this is something that's like on the periodic table or something you can just know. Silver has a charge of +1, and this has a charge of -1. So when it's over here and there's a charge of -1 here, this must be a charge of +2 because we cross those 2 things together, right? Or you can say that the charges have to cancel out, right? So you have 2 of something that is -1, so you have -2 over here, we could say. -2. What has to be over here in order to cancel out those charges? This has to be a +2 right here, -2 there. So copper is +2. Cool. So now what we can also look at is the silver. So as I said before, silver has a charge of +1. Most of the time, and in this situation it does. So we have 2 silver, so we'll do 2 Ag that are +1, and then it becomes 0, right? So you have 2 Ag 0. So now let's figure out if something has gained electrons or if they've lost electrons, right? So copper, let's look at copper right now. So when something bears a positive charge, does that mean that it has gained electrons, or does that mean that it has lost electrons? So that means that we have lost electrons, right? Because when you gain electrons, something is negative, so that when you lose electrons, something becomes more positive because you're losing the thing that is negatively charged. So in this situation, copper, we can see here, has lost 2 electrons. And then silver here has gained 2 electrons because you would multiply these 2 together. So you have +2 electrons, and in order to go from +2 to 0, you have to, let me write here, lost 2 electrons, and then here we gain 2 electrons. Right. So now we have to think about our little acronym, right? So we have Leo says GER. Oh my god. Leo says GER. So we know that something that loses electrons is oxidizing. So I'm going to write that in, like, put my answer in red, I guess. And orangey color. So this is oxidizing. Oxidized, we'll say. Oxidized? Why did I add a Z in there? I don't even know. Oxidized. There we go. So copper is oxidized. Copper. Copper is oxidized. And then we can see here that silver. So we see that gain of electrons is reduction. We are gaining electrons, so silver is reduced. And we also know that when something is oxidized, it is the reducing agent. Reducing agent. Copper is oxidized, and it is the reducing agent because it's causing silver to be reduced, because copper is actually taking or giving its electrons to silver. Actually, like, this means that it's losing, by the way, and this means that it's gaining. That's what that positive and minus means. Okay, so silver is reduced, and then it is the oxidizing agent. Agent. Right. So this would be your answer here, right? Copper is oxidized and it is the reducing agent, and silver is reduced and it is the oxidizing agent. Okay. So I hope that all makes sense. I'm going to go through the one thing one more time just because it can be a little bit confusing when you're thinking about why is it the reducing agent and why is that the oxidizing agent, right? So copper. Let's look at copper. Copper loses 2 electrons. and silver gains 2 electrons. Where do you think silver gets those electrons from? It gets them from copper, right? So copper is causing silver to be reduced, and silver is causing copper to be oxidized. Therefore, silver is the oxidizing agent because it's the one that's helping copper be oxidized, and vice versa. I hope that makes more sense because that's how I think of it, and I'm hoping that kind of explains some things there. I'm gonna be right back. I'm gonna let my dog out of my room because she's been whining for a second, and then we'll get into practice. Okay, apologies for that. So let's go on to here for practice. So I'll leave the screen up for a second if you would like to pause and try this out. Okay, so I went ahead and I did this out, and I have my answer here. So I'll kind of like run you through my method of madness. So first thing that I did is I underlined which things would be the metals that are gaining the electrons or losing the electrons. So first I started out with manganese. So I had 3 manganese at a charge of 0 because it was a solid, and then it went to a charge of +6 because there were 3 with a charge of +2. How I knew that it was a charge of +2 is because I just used the periodic table, and it's in the second group, so that means that it usually loses 2 electrons in order to get to its happy octet. So I said that because it was losing electrons, manganese was oxidized and is a reducing agent. And then for chromium, did basically the same thing. Chromium has a charge of +3 in this situation, and I knew that because this compound here, acetate I believe it is, has a charge of -1. And when you cross the charges there, we can see that chromium would have a charge of +3. Right, so we have 2 chromium there with a charge of +3, which means that it has a charge of +6 in total, and it's going to make a product that has a charge of 0 because there's 2 chromium. That's a solid, and solids don't have any charge to them, so it would have a charge of 0, right? So in this situation, you are gaining electrons, so you're going from positive to neutral, so that means you have to gain something that's negative. So I said that chromium is reduced, and it is the oxidizing agent in this scenario. So thank you all for watching the video, and if you guys have any questions, as always, feel free to reach out. Thank you.